Hi guys, and welcome to another video. Today we're going to be looking at a video on the fundamental counting principle, and we're going to be looking at codes from a word using vowels and consonants. The question that we're looking at is from the November 2013 paper 3. It reads as follows. The 9 letters of the word equations are used to form different 5-letter codes. How many different 5-letter codes can be formed from the 9 different letters in the word equations? First thing that we need to look at is how many letters in the word equations. And they tell us here that there's 9 letters, so therefore n is equal to 9. Are used to form different 5-letter codes. The number of places is going to equal to 5. So n is equal to 9. That is the number of items that we have to arrange, and r is equal to 5, which is the number of places that we have to arrange them in. How many different 5-letter codes can be formed using the different letters in the word equations? One other thing that we have to look for, if there's any repeating letters. As we can see, E, Q, U, A, T, I, O, N, S, there are no repeating letters. Therefore, 4.1 can simply use this formula, which will be how many different 5-letter codes can be formed. So we know the value for n and r, so we can use the equation n factorial all over n minus r factorial, which would equal to 9 factorial all over 9 minus 5 factorial. We can now put that into our calculator, and that would be 9 factorial all over 9 minus 5 factorial. That will equal to 15,120. So that's 15,120. Alternatively, we could look at it like this. There are 5 positions that we have, or 5 places. 1, 2, 3, 4, one more, 5. And we have 9 letters. So n is equal to 9. So the number of items that we have to arrange is 9. So therefore, it will be 9 times 8 times 7 times 6 times 5. 9 times 8 times 7 times 6 times 5 equals to 15,120. So that's 15,120. Now, remember that they tell us different 5-letter codes. Therefore, this is an example involving no repetition. So in the first position, you have all 9 letters to choose from, so you can choose any 9. Once you choose the first letter, then you'll have 8 letters to choose from. Once you choose the second one, you'll have 7, and so on until you come to 5. And that's why we use factorial notation to answer this question. Let's look at 4.2. It says, how many different 5-letter codes can be formed from the letters in the word equations by using all consonants and 1 vowel? So once again, we have 5-letter codes, 1, 2, 3, 4, 5. So let's just look at this question in more detail. It says how many different 5-letter codes can be formed from the letters in the word equations by using all the consonants and 1 vowel. Let's see. So how many consonants and how many vowels do we have? So let's look at that. So we can clearly see here that vowels will be E, U, A, I, and O. So we have all our vowels. A, E, I, O, U. So that's 1, 2, 3, 4, 5. So there's 5 vowels, which will leave us with 4 consonants. Which now means that if we answer this particular question, it tells us that we have to use all the consonants and only 1 vowel in each word. So therefore, we can have a vowel and a consonant here. But if you look closely, this would now be 1, 2, 3, 4, 5 places. So therefore, this is now 5 factorial. However, remember that the vowel now can move from this position and it can go here. And if it goes there, then you can have a consonant in all the other places. A vowel can also be there, can be there, and also there. So therefore, you can have 5 factorial and the vowel can be in 1, 2, 3, 4, 5 different places. So the solution to this particular question will be 5 factorial times 5. That would equal to 5 factorial times 5 equals to 600. So we can have 600 different codes. Learners, if you haven't subscribed already, don't forget to subscribe to JR Maths. You can also check all the videos from all grades on jrmaths.com. And I'll catch you in the